Good morning, students. Today we discuss about ionization energy and electron affinity relation with thermodynamics. We will discuss about this topic. So here we know that the thermodynamical relation is different from the normal relations. So we are considering system and heat capacities and everything. So here we are discussing about from thermodynamics, ionization energy and electron affinity. So here at absolute zero temperature, so at absolute zero or at any other temperature, heat capacities of reactants and constants. So we have taken heat capacities Cp and Cv. So volume at constant volume heat temperature, at constant volume heat capacity, at constant pressure heat capacity we are considered. So here enthalpy of the reactions. If you take any reaction, for example, any reaction. So for example, ionization is considered as one reaction. Electron affinity is considered as one reaction. Therefore, here any metal gaseous element minus one electron n plus, that is called ionization. So here this process is called as ionization. So and simultaneously we take electron affinity. What is electron affinity? When an electron is added to the neutral gaseous atom, the amount of energy released is called as electron affinity. At temperature T is delta Z naught, T equal to delta R plus, so for example Cp dt. So dt means, so heat capacity at constant pressure. So this is the equation we derived. So absolute zero to temperature T. So this is considered. Integration equation we are considered. So Cp value equal to 5 by 2 R. Anytime if you are taking Cp, then we take 5 by 2 R. And then if you take Cv, that value is 3 by 2 R. Therefore here we have considered Cp value only, heat capacity at constant pressure. So here Cp are considered plus 5 by 2 R for ionization reaction. Okay. So next one, Cp for electron affinity minus 5 by 2 R for electron affinity. Therefore, delta H value equal to an ionization energy, ionization enthalpy, that is ionization enthalpy is considered as ionization energy plus 5 by 2 RT. This is the thermodynamical equation of ionization energy. After that, delta G naught of electron gain enthalpy for electron affinity minus A, electron affinity minus 5 by 2 or T. So this is about thermodynamical relation. So for ionization enthalpy, ionization energy plus 5 by 2 RT. For electron gain enthalpy, electron affinity minus 5 by 2 RT. So this is about thermodynamics relation with the electron affinity and ionization energy. After that next, trend in variation of electron affinity in a group and period. Next topic is variation of electron affinity electron affinity in a group and in a period. So electron affinity in a group and period. Actually, in a group, electron affinity values are gradually decreases. So in a group, first we consider in a group from top to bottom, electron affinity values are gradually decreases because atomic size increases. But we are taking some exceptional cases. So first element having less electron affinity than the second element. So like that we are considered. So I will give an example for this. For example, if you take halogens, fluorine, bromine, iodine. So but actually decrease means like this. But actual order is fluorine, bromine, iodine. So this is the order. So chlorine is greater than, bromine is greater than iodine. So this is in case of halogens. Why chlorine having more electron affinity than fluorine? That is the reason. So in any group we are taking same thing will repeat in the 6th group, 5th group, and also 4th group also. So 4th group also same thing. 4th group also same thing. 4th group carbon, silicon, germanium, tin, lead. Therefore, the order is also silicon having more electron affinity than the carbon. This is in case of 4th group elements. And in case of 5th group elements also. 5th group elements nitrogen, phosphorus, arsenic, antimony, bismuth. So phosphorus having more electron affinity than the nitrogen. So this is in case of 6th group is also. So 6th group means this is order is like this. 6th group order is oxygen, sulfur, selenium, tellurium. But sulfur having more electron affinity than oxygen. This is in case of 6th group. But in case of 6th group, the order is sulfur, selenium, tellurium, last oxygen. Sulfur, selenium, tellurium, next to last oxygen. So this is the order in case of 6th group, electron affinity. So first we will discuss about why chlorine having more electron affinity than fluorine. What is the reason? So whatever in 4th group silicon having more electron affinity than carbon. This is in case of 4th group. In case of 5th group, this is the order. In case of 5th group, so this is the order. And in case of 6th group, means in case of 7th group is also like this. So what is the reason why chlorine having more electron affinity than fluorine? I will explain here. The electron affinity of chlorine is more than fluorine. Why? What is the reason? Because here chlorine fluorine atomic size is very less. 1s2, 2s2, 2p5. So here one shell and here two shell. If you take chlorine atomic radius is larger than this one. So this is the size of chlorine, this is the size of fluorine. So when an electron is added to the fluorine, what happened? Already electrons are present. And already present electrons and newly added electrons, repulsions take place. So due to repulsions, the released energy is less. But in case of chlorine, the atomic size is larger. Repulsions are very less when compared to fluorine. Therefore, in case of fluorine, smaller atomic size and repulsions between the already present electrons and newly added electrons. Because of that repulsions, the released energy is less in case of fluorine. So the released energy is smaller size and strong inter-electronic repulsions. That is the reasons. So here I will explain here. So first reason is smaller size and high interactive repulsions of electrons. High interactive repulsions of electrons. Therefore, due to these two reasons, fluorine having more electron affinity than fluorine. So chlorine electron affinity is more than fluorine. So this is the reason for the electron affinity of chlorine is more than fluorine. So first element in 4th A group, 5th A group, 6th A group and 7th A group having less electron affinity than the next element. So in case of 5th A group elements, nitrogen having less electron affinity than phosphorus. So that is the reason. And also in period we'll discuss about this is in case of group. So in a period from left to right, electron affinity values are increases because of effective nuclear charge increases. So that is the reason. Decrease in size and increase in effective nuclear charge. This is also decrease in size. So this is about electron affinity.